Hello friends, it is NPTEL Compiler Design Assignment 4. Coming to question number 1. Words of a language constitutes. Words of a language constitutes only terminals, not non-terminals. Means suppose I do have a grammar S tends to capital A small A tends to small b. Now what are the words what it can generate if S is A, later this A is replaced with B, means it is going to represent a word BA. Now what is B and A? Those are called terminals, means words of a language constitutes set of terminals. Now look for question number 2. The grammar E tends to E plus T or T tends to T star F or F or ID is. This is called unambiguous grammar. Why? Because if I have to construct a parse tree for the input sentence ID plus ID star ID. How to construct a parse tree for this input sentence? We start with the starting non-terminal. So among the many alternatives, E tends to E plus T only is the correct alternative. So means only one possibility is there. This E should become F, F should become ID. So this ID is derived and this plus is also derived. Now with T, I have to get ID star ID, means this T is to be replaced with T star F. So this star is derived. This T and F, now it has to be represented with ID, means T should go to F, F should go to ID. Here also F should go to ID, means ID plus ID star ID. So means for this input, how many parse trees are generated? It is generating only one parse tree. So we call the grammar is unambiguous. So answer for the question number 2 is option B. Question number 3. The grammar E tends to E plus E, E star E or ID is. Here, this grammar is called ambiguous. Why? Because let us say an example ID plus ID plus ID. For this input sentence, I can able to generate a parse tree for the input sentence by using a production E tends to E plus C. It is a first possibility. Now this plus is generated. Now I can assume this plus may be this one or this one. If I assume this plus is this one, this E is to be replaced with ID. So that ID is possible, plus is possible. If I assume this plus is this one, then it is going to give you one more tree. E tends to E plus E, right? Now, if I'm assuming this is plus, this E is going to become ID. To get remaining ID plus ID, here this is to be replaced with E plus E. In this example, this is to be replaced with ID and ID. Here also similar thing, E plus E and to be replaced with ID and ID. So means ID plus ID plus ID. So for the input sentence, because it is generating more than one parse tree, such grammars are called ambiguous grammars. So answer for question number 3 is option A. Question number 4. For a context-free grammar, left-hand side of a production rule should contain. In a context-free grammar, left-hand side of a production should contain single non-terminal. Here, what is the format of CFG? That is A tends to alpha. That alpha in the right-hand side contains non-terminals or terminals or any combinations of these. We can call V union T star. The LHS contains only one non-terminal. We can call single non-terminal. So answer for the question 4 is option A. Question number 5. A grammar is ambiguous. Just now we have discussed. A grammar is ambiguous if it generates more than one leftmost derivation or more than one rightmost derivation. What does it mean? The ambiguous grammar generates more than one leftmost or more than one rightmost. Means more than one LMD or we can call more than one RMD. Now look for the option A. Its leftmost and rightmost derivations are different. Because it is different, it is incorrect. It need not be different, maybe same also possible. More than one leftmost derivation exists. It is a true statement. There is no leftmost derivation, false statement. There is no rightmost derivation, false statement. So answer for the question is option B. Now coming to question number 6. A grammar with production rules, this is given, contains left factor, left recursion, both left factor and left recursion, none of the other options. What is left factor? If two productions having, this means if a production with two alternatives having common parts of RHS. Look, A is having two productions. but this is B, this is C, different. B is having one production, C is having one production, means you don't find any common parts of productions, so that it is not having any left factor. Option A is incorrect. Left recursion, option B. What left recursion says is, left recursive productions are of the form A tends to A alpha. It does mean that leftmost symbol in the RHS should be same as LHS. If leftmost symbol in the RHS same as LHS, we call left recursion. Now see, A tends to BA, B is not same as left LHS A. C is not same as LHS A. C is not same as LHS B. So means here no direct left recursion. But I can say the left recursion existed, indirectly may be possible. Here let us see an example. A tends to BA is a production. This B, if replaced with CA, CAA, this C may be replaced with small c or epsilon. Suppose that this C, if replaced with epsilon, then it is going to be AA. Now it is a production whose leftmost symbol in the RHS same as LHS. Then I can call it is having a left recursion, but not having direct left recursion. Instead we can call more specifically indirect left recursion. We can call left recursion existed. So answer is option B. For top-down parsing, left recursion removal is mandatory. Why? Because we have discussed left recursive grammars are of the form A tends to A alpha. So what it will do is, when it is going to derive an input sentence, it will apply a production A alpha. Again it has to replace the leftmost non-terminal first. Its production is A tends to A alpha. Again leftmost non-terminal it has to replace. Again its leftmost non-terminal is A tends to A alpha. So here what is happening, the tree is queuing to the left continuously, so that handling such grammars are difficult. That's why top-down parsings requires left recursion is to be removed mandatorily. So answer for this question is option A. Question number 8. Derivation produced by top-down parser. Here we do have two types of parsers called top-down parsers and bottom-up parsers. Here the concept is, all the top-down parsers uses leftmost derivation and all the bottom-up parsers uses rightmost derivation in reverse, and it is an important point. Now question is, derivation produced by top-down parser is leftmost, that is an option A. A predictive parser. Here the predictive parser, it is naming that if I look for more than one alternative, among the more than one alternative, by looking its first terminals, it can able to make a decision. It can able to predict which production rule is best suitable. That's why the name predictive, because it is able to identify the correct production rule it has to apply. Then it doesn't require the reversal of a production and apply for the second alternative or next alternative possible. Suppose if you apply for one alternative, if this is you feel not suitable, then it has to reverse it and check for the next alternative. Trying for first, if not suitable, trying for second, this process is called backtracking. But in predictive parser, it is possible to predict which among the two, which production is best suitable. So means it doesn't require any backtracking, means we are always predicting the correct alternative to apply for the derivation process. So means in the options are given needs backtracking incorrect, does not needs backtracking is correct. So answer for the question number 9 is option B. Question number 10. For the grammar rules, S tends to AA, BB, A tends to C or epsilon. The first of S. What is first of S? Means S is going to start with what terminal symbols. Now here we have a production S tends to AA. Now I can call first of S equal to first of A, because it is starting with non-terminal A. For A we have two productions, A tends to C or epsilon. Because A tends to C or epsilon, then I can call first of A equal to either C or epsilon. Then here what is first of S is first of A. First of A is containing C, and possible that is also replacing with epsilon. It means if this A replaced with epsilon, now it is just like a production S tends to small a. It means that what is the terminal possible with S A? So that what is first of S, both A comma C. It is based on the first production S tends to A. But S is having two productions. What is another production? S tends to BB. So that what is first of S from this production? The terminal which is appearing at the first position of its RHS, that is B. So that what is the final answer for first of S based on the first alternative that we found A comma C, based on the second alternative we found B, so that first of S is all A, B, C. So answer for this question is option C. Thanks for watching. Please like, share and subscribe.